Hi everyone. So this is an introductory video about containers and Kubernetes, and in this video I'll be talking about what they are and why there's something like this exist. All right. So before getting into the technical details of container and Kubernetes, uh, I'd like to talk about software development in general. And we as software developers, we are focused more on uh, coding and developing the software, but that's not the end of it. At the end of the day, you have to ship that software to the users, right? You have to deploy it somewhere, and deploying an application or a software has its own set of challenges. So I'll use a very simplified example of an application deployment here to sort of highlight the problems that uh, a software developer would face while deploying the application, and even after deploying, uh, they would have to upgrade and then scale, and what are the challenges that would sort of arrive, and then how something like containers and Kubernetes solve it. All right. So let's consider this example. So let's say you have your app and then you want to take it to the users. So let's say you get a server with two CPU, these would be virtual CPUs, and 4 GB of memory. So when you get a server, you probably install the required OS, or probably server comes your uh, with an OS that suits your needs, and then in that you install all the libraries that are needed for your application to run, and then eventually you either clone and build your app binary inside the server, or you just copy the binary inside the server from somewhere. So after this step, your server is already connected to connected to the internet. It has a certain IP address attached to it, and then you get a domain for your server, and then sort of map the IP address for the domain name. So whenever the users hit that domain URL, the traffic is routed to the server, and your app is listening to the request, and then it responds to the request made by the users. So this is a very simplified version of a deployment uh, scenario. So let's say your app is doing pretty well, and then after a certain time, the traffic uh, on your app increases, and there are a lot more users that are using your app. So since there's a lot more request to process by this application, uh, this server specs might not be enough. So you might want to scale it up, right? So let's say you increase the CPU to 8, you increase the memory to 16 GB. Now, what we just did here is something known as vertical scaling. It essentially means that we are making this one server box more stronger, essentially adding more compute and memory to it. There's or we could do this, or there's another option which is also known as horizontal scaling. In that case, what we would be doing is we would be getting another server of similar size, and then we would have our application deployed on that server. But either way, we have to sort of manually do all those setups and configurations to make all of these things work. So this can work if you have like 4 or 5 users, but as soon as your app starts getting uh, complex, and then you start getting more users, it's very hard to maintain such a setup. And I'd like to point pretty common problems that such kind of setup would face. All right, so the first point is that we are setting up things manually here, right? And there's a pretty funny meme in software community that people say that it works on my machine, but it does not work on yours. So setting up on production or server or somewhere else has its own challenges if done manually. It might work on your local PC, but then while setting it up on the server, there can be some misconfigurations, there can be other issues due to which the application might not just run, and it can just take some time to configure it and make it work. Another problem is that if we scale vertically, then there is this single server that has the application running, and let's say the data center has some power outage or something went wrong or your application crashed, then that's it, the application is down and the users are not getting served their requests. So this kind of setup acts as a single point of failure. So it's and even if we, let's say, scale this single server by adding more specs, it at after a certain point in time, it really gets hard to sort of scale vertically, because there's only so much CPU and memory that you can add to a single box. And scaling horizontally in such scenario and in such setup is also challenging, because configuring different servers and then setting things up is just complex, and it's time consuming, and it's not streamlined, and it's hard to scale that way. At scale, everything breaks, and as soon as the scale of the apps would start increasing, the software itself would uh, start getting complex, and at that point in time you might not want to have a single application that contains your front end, your APIs, your database, everything into it. So you might want to break it into smaller microservices, and with such setup, managing microservices would be very painful, because now you don't have a single application receiving request, you have multiple smaller microservices where you're getting request to your front end, and then it is passing to that request to your API service, and then there are other database services that receive that request from the API service. So there are a lot of things into play here. Your different microservices need to talk to each other, they need to route the request properly, they need to be able to communicate properly. So that has its own challenges, and such setup is just likely gonna create a lot of friction to get all these things running. And it's not just that you deploy a software once. I mean, we there are bugs, there are features that get added to an app. So upgrades are needed, and upgrading in such setup is very painful, because uh, let's say you have a single server box, you try to upgrade it, and then whenever you upgrade it, your app goes down because it's upgrading, right? So all these, there are a lot of other problems as well that I have not covered into this slide, but I was just trying to sort of give you a taste of what are the challenges that you would face with such deployment setup. So this brings us to our next slide. So what are containers? So as I mentioned earlier, the problem of having to set up and configure the apps in different environment manually is error prone, not streamlined, and can lead to sort of challenges, and it will just add up to your deployment time, right? So in order to solve that, containers were created. Containers are essentially just a bundle of your application code, its libraries and dependencies that are just packaged into one unit, and that unit is known as image, which we call container image. So what happens with this is that when you create a container image, all of its dependencies and its configurations are inside that image, and you can just use uh, one line of command to get that container image running. There are other things such as container runtime and container engine that come into picture here, but we'll get into that later. To keep things simple for now, That is what containers do, right? They just package everything together into a single image, and you can use that same image into different environments. So if it works in your local PC, it is going to work in your dev, it is going to work in your production, so you don't have the problem of it works on my machine, right? So as an example, I just have a Docker file here. uh, so what this file is, even if you don't know what Docker is and what it does, we'll cover that later. But I just wanted to show you, this file has comments. So what this file is doing is that it is building a container image for a Golang application. So as you can see, at stage 1, we get a Golang version. So let's say I'm using Go 1.22, right? And then I go to an application directory, I copy my all the modules and libraries file inside that directory, I download all the modules, and then I copy the entire source code in that directory, I do all the configurations, and then I run go build command, which essentially builds the application binary for me. And eventually we expose the application port, and then we trigger our binary, which is this dot slash main command. So that is it. And as soon as you run this image in any environment, you have your Go application up and running without any issues. Alright, containers are great, but they just solve a part of the problem. A real production environment will have more than one container running, and to orchestrate those multiple containers, something like Kubernetes comes into picture. Consider the following scenarios as use cases which Kubernetes solves. So all these containers would need to communicate to each other, right? And based on their application architecture. Kubernetes provides that underlying network setup out of the box for all those containers. These different containers would serve different purposes, and based on that, the volume of request they receive will vary as well. If a container has high volume of requests coming in, we would want to scale it up independently of the other containers. And apart from just scaling it up, we might need a load balancer as well, so that the incoming request is evenly distributed among the replica of that particular container. Kubernetes provides the ability to scale the containers independently of each other, and provides load balancers to route the request to different replicas to distribute the traffic evenly among those replicas. Also, having multiple replicas per container would solve the single point of failure issue that we had discussed earlier. And in scenarios where our container crashes due to some intermittent issue, Kubernetes will restart those containers and will try to keep them running. Regarding upgrades, Kubernetes provides rolling upgrades, which means we can upgrade the application without taking the entire app down. With rolling upgrades, we first upgrade a subset of replicas, and once that subset gets upgraded successfully, we move on to upgrade the rest of the replicas. Personally, I think of Kubernetes as an application state manager, where I just need to provide a configuration defining the desired state of my application, and Kubernetes will take care of everything to ensure the desired state of my application is maintained. This is a very simplified and boiled down definition of Kubernetes, just to give you the broader idea of why something like this exists and what kind of problem it solves. In the further videos, we'll be going into much more detail of what Kubernetes is and its actual technical details. So I think that would just be for this video. See you guys later.